Hi, this is Tim from Tiger Astronomy, and the Tiger Automatic Observatory has been observing asteroids tonight, and I wanted to just show you the process of detecting the asteroids and making a report for the Minor Planet Centre. So I'm going to use this piece of software called Visual PinPoint, which comes with ACP, Astronomer's Control Program. It's part of the package, and it's not a very inspiring looking user interface, but it's a very powerful little bit of software. So the first thing is we need to add some files in here, and when we take the images, let's just see if I can find them. They're in ACP scheduler images. Okay, under my directory, today's folder. So here you can see some of the targets, and so this one, 451 Patientia or something. As you can see, we've taken 4 separate images of each asteroid, and they're spaced about 15 minutes apart, so that's not immediately apparent from the timestamps here, because these files were calibrated with dark frames and bias frames, and obviously all done at the same time. But if we open this file up, we just double click it. Oh, that's gone into there. That's okay. Let's do this again. So we'll add all those files. There we go. And I've added one of them twice now. I better do that again. Okay, so I'll tell you what, let's do what I was going to do, which is open one of these files up. And this is a program called Fit Liberator, and we can look at the header files. So we can look at the image headers, and here you can see all the details of the image and when it was taken and so on. And you can see this was taken, date observed, at 22, 36 and 56 seconds. So 22:36, and then if we look at the next one, you can see that was taken at 22:47, so a little bit over 10 minutes later. And that's enough to be able to see an asteroid moving against the background star field. So if we take those 4 images and drop them in, and in fact I'm going to do a load more images at the same time. Let's sort by type so I can just group them. Okay, I'm going to drag those in, and those. This one has only got 3 images because that's actually still in progress on the observatory, but 3 images should be enough, so let's try it. Herculina. And there you go. And Interamnia. There you go. Now these are all following advice from the Minor Planet Centre. These are all low numbered minor planets in the range 400 to 40,000. So they're not the very brightest ones, but they are some of the brighter, more easy to detect minor planets. So I'll explain why I'm doing that in a moment. These are earlier experiments, I won't put these in. So the first thing we need to do is we need to ACP will have actually plate solved all these files, but I want to resolve them because I'm going to use the UCAC4 catalogue. And if we look in solve settings here, you can see I'm using the US Naval Observatory UCAC4 catalogue. And so we'll go back to solve. Where is it? Solve plates. Okay, so we can say force imagery scan, always add world coordinate system, and then just hit solve plates, and PinPoint will rush through all those images and plate solve them, and away it goes. That noise you can hear is the observatory moving and triggering the CCTV camera, which sends me an alert. So at the end of this, once it's plate solved all these files, oh, now see what's happening now is because I've got the astrometric cataloguers in OneDrive, and OneDrive doesn't keep a local copy of anything you haven't accessed for 30 days. So the catalogue is being downloaded on demand by OneDrive. And that can take a little while initially, but you soon get a working set of the files you need, and then it doesn't take any time after that. It took longer than I expected, actually. Okay, so on my other screen, which I'll just pull over, we have a report file. Okay, so here we are in Visual Studio Code, and okay, so here are all the files. So the first file here, solved using 34 out of a maximum of 1,000 stars, and it found 125 catalogue stars. So you can, it tells you the measured center point of the image and the roll angle, the sky position angle here, the full width half maximum of the stars in the image, and they all seem to be about 3.5 to 4 in this set of images. So anyway, I'm going to close that, and then we can pop over here to the Find Asteroids tab, and we'll just click Get Solved to get all the images we've already plate solved, and there they all are grouped into their 4s, all except for this one, which has only got 3, so that will be Carver. And then we're going to blink all the images, and we are not going to force a rescan because we've just plate solved, and that's fine. So we'll click Find Asteroids, and Visual PinPoint whizzes through, and here we go. This is our first image, and as you can see, it already knows that we've got an asteroid in this image. It's highlighted it for us. If we put the mouse over it, you can see up here there's a little magnifier window. You put your mouse over it, you can see it in more detail. And so that's a good detection, I would say. This here tells us that, or the help file, let's just resize this window because it's crazy. There we go. So we're looking at a main belt asteroid there, or possibly a Trojan. Let's it's about in the middle and slightly off to the right, so yeah, about here. It's probably a main belt asteroid, I would say, and we can accept that as a valid detection, and then we can say we want to. Oh, it's asking me to accept again. I think that's the thing. Alright, so now it's turned blue because we've accepted it, and we can now tell it we want to report that detection to the Minor Planet Centre. And something strange is going on here. Oh, after that we've got to click Done. There we go. And then we get the next image up in sequence, and here's our next detection. Again, that looks like a good detection, so we're going to accept that. And it's turned blue. and then we'll report it and click done. Okay, now there's a little galaxy up here in this image. Okay, now this one's interesting. The second image has got a bit smeared here, and Visual PinPoint hasn't automatically detected it. So what we can do is just click on the image to stop it blinking, and then we can go in and click on the asteroid we've detected, and then we can step to the next plate. Now, because that's a bit blurry, I'm not really sure whether we should use that as a valid detection, so we'll skip that and go on to the next plate. And again, we'll click the asteroid, go on to the next plate, and again click the asteroid, and back to the beginning. Okay, so 1, skip, 2 and 3. 1, skip, 2, 3. Okay, and we can put the automatic blinking speed back up again. Okay, and so we can then say we want to report that, and we're done. And here's another one. Now, again, that's got a blurry image, and I'm not quite sure whether we ought to accept that or override it. This actually looks like 2 detections. I think we ought to possibly. I think that's unsafe. I'm going to reject that. And let's go to manual. I don't want to report anything there. I'm trying to remember how to. Let's clear. Okay, so I don't think I'm going to report this. That's an unsafe detection, I think. So, oh, there's another one. Okay, now I don't know what happened to this image. There's another galaxy in the image here. I think this is the asteroid here, but I can't be certain because we've got double stars in one of the images and it's all a bit, yeah, I won't use that. And I think, oh, there's one more, and this looks like a good clean detection. Okay, so there is a double image there, but Visual PinPoint's really happy with that. So we'll accept and report, and we're done. Now again we get a report file output in Visual Studio Code, and this gives us a file, this metadata in a format that's required by the Minor Planet Centre, and then a list of all the objects we've detected and their positions, and most importantly an accurate date and time. The time on the observatory computer is maintained to an accuracy of probably plus or minus 10 milliseconds, I would say. So it's very accurate, and so these are the magnitudes of the items we've found. So as you can see, it ranges from 11 to about 12.6, and on the end here, the 999, that's our observatory code, which 999 means you haven't got a code, it's a temporary designation. So these we won't submit this to the Minor Planet Centre yet, because what we need to do is to observe these same objects over 2 to 3 nights. Ideally sequential nights, but particularly in the UK, the weather gets in the way, so they can be several days apart. And if we can get some consistent readings over several nights, then we can send the file generated in just exactly this way off to the Minor Planet Centre, and they will give us, they will basically check our observations and make sure they meet the required accuracy levels, and then they will issue us with an observatory code, which will then go in here in all our future reports. And that means that they are prepared to accept our data as being accurate, and we can make observations of asteroid positions. So that's really cool. So that's the process. That's all I wanted to show you. I've been Tim from Tiger Astronomy. Thanks for watching, and good night.